Hello everyone! In this video, we will see how to implement an Interact interface in Unreal Engine 5. The first thing we need to do is to create a blueprint. In this case, what I want to create is a blueprint interface. You simply have to right-click in the content browser, choose Blueprint, and then Blueprint Interface. I'm going to call that BP Interact Interface, and I'm going to open it. The first time you open that, you should see a new function here, and we're going to name this new function Interact. And when it comes to the blueprint interface, that's all we need to do. So just click on Compile and then Save. We will use this interface on interactable objects so they can have this function and we can detect if there's an interaction or not. Now that we have an interface, we need some form of input, so we need to create that. In my case, I'm using the first-person project, but I'm assuming you have something similar. This works for the first-person template or the third-person template. I'm going to look into the input folder, and into the input, I'm going to look into the actions folder. I'm going to right-click, look for input, and I'm going to create a new input action. I'm going to call that IA Interact, and in here, I'm going to add an element to the triggers array, and in triggers action, I'm going to look for pressed. I'm going to save this, can close that too, and now in the input folder, I'm going to open the IMC default. The IMC stands for Input Mapping Context, and we can see in the mappings array here that we have three actions already, the base actions of the first person template, jump, move, and look. I'm going to add a new mapping here, and I'm going to select the input action we created, so IA Interact, and in the drop down of this new mapping, I'm going to choose the key to use to interact with objects. In this case, I'm going to click on the select key value here, press E on my keyboard, and this will automatically detect that my interaction can be E. Otherwise, you can look directly into all the components if you want to have something else. Here, I'm just going to use the PC components, but you can also add more mappings if you want to. So if you use a controller, you can add that on top of the keyboard input. So in my case, I'm just going to focus on the keyboard for this tutorial. So I can close that now. Now all we have to do is to actually have some objects we can interact with. So the mapping is done. We can have interactions from the player point of view. We have a blueprint interface to detect interactions. Now we simply need the object to interact with. So I'm going to create a new blueprint. So right-click in the content browser, look for blueprint. I'm going to get a blueprint class. I'm going to choose actor, and I'm going to call that BP Interactable. I'm going to open this blueprint. I'm going to add a new component, and I'm going to look for a static mesh. So I have this cube here. I'm just going to name that mesh instead of cube. Now I'm going to add a collider to this blueprint. So I'm going to look for box, in this case box collision. Instead of calling that box, I'm going to call that interaction bounds. I'm going to change the scales of the values here, like so. So what's happening here is we have our mesh, which will be the object we want to interact with, and we want a field around the object that will be bigger than the object. So when the player enters the bounds of this interaction, we will be able to interact with the object. So now we have a mesh, we have some interaction zone, but we still need to implement the interface we created at the very beginning of this video. To do that, click on the class settings on the very top menu, and at the bottom of class settings you can see interfaces, and we can see that there is no interface currently used for this blueprint. So in the implementing interfaces section, I'm going to click on add, and I'm going to look for BP Interact Interface. When we look at that, now we have the Interact interface appearing at the bottom here. If I double click on that, I can see that it creates a custom event in the event graph. In this case, I don't need to have anything. I'm going to compile, I'm going to save, and we'll come back to that in just a minute. Now we almost are done. I just need to change the first person blueprint. So I'm going to go into the first person folder, go into blueprints, and the BP first person character. can see that in the event graph we already have a few functions happening. We have the jump function, we have the movement input, the camera input. I'm gonna create a new action here. So I'm gonna look for enhanced action. You can see we have all the actions we mentioned at the beginning of the video. So in this case, I'm interested into the IA interact. In here, I'm gonna create a new node starting from the triggered action. I'm gonna look for a for each loop with break. There's a lot of things happening with the for each loop with break. So the very first thing we want to do is to get an array. From this array, we're gonna loop from inside this array to find elements that we are looking for. In this case, I'm gonna look for get overlapping actors. The reason we're doing that is if I go back into my BP interactable, we have an actor here, we have some collision bounds here that are meant to detect the interactions. So this is exactly what we're doing here. We want to get actors that are overlapping with the first person character. In this case, I want to select a class filter when I look for BP interactable. Every time we want to interact with an object, we're going to loop into the objects that are in front of us by looking into the overlapping actors. If this actor that is overlapping with the first person character is an object that can be interacted with, so it has the interactable blueprint, then we can implement the actual interaction. So from the loop body, I'm going to go into branch, I'm going to create a branch, and from the array element, I'm going to look for a node called doesImplementInterface. We want to check if the object we found does implement an interface. And in this case, we want to look for BP interact interface. If this is true, we're going to connect the value that this function returns into this branch. So it means that if the object we are interacted with does implement an interaction interface, if that's the case, I'm simply going to implement some printing and say that the text will be interaction. And since this is true, we're going to connect that back into the for each loop with break, and we're going to connect that to break. So once we found some object we can interact with, then we can stop the looping. There is no need for that anymore. So we just implement the break here. Now I can save that, and everything should be ready now. So I'm going to put this blueprint interactable on the map. You can see it right here, and we can see the bounds. And I'm going to go into play mode. I'm next to the object. Right now there's nothing happening, but if I press E on my keyboard, we can see that there is some interaction. If I go next to those cubes, press E, nothing is happening. Same thing, I can go anywhere, keep pressing E, nothing is happening. But if I get to the cube, we can see the interaction is working. So that's it for this video, and I will see you in the next one. Hello everyone. In this video, we will see how to implement a UI interface to display when the player is about to interact with an object. The first thing we need to do is to create a widget. So I'm going to right click in the content browser, look for user interface, and I'm going to choose widget blueprint. I'm going to choose user widget here, and I'm going to rename that widget interact. I'm going to open this, and in the palette on the very top left, I'm going to look for a canvas panel. I'm going to drag and drop this canvas panel under the widget interact. Then I'm going to look for a vertical box, which I will also drag and drop under the canvas panel. Then I'm going to look for an image, which I will drag and drop under the vertical box. And finally, I'm going to look for a text, which I will also drag and drop under the vertical box. I'm going to change the default text to interact. As we can see right now, we have a text and a blank image on the very top left corner. However, if the player interacts with that, this will be displayed in a strange way. I need to center everything. So inside the vertical box, I'm going to click on anchors and select the middle anchor. The moment I do that, we can see that the anchoring is going to be centered horizontally and vertically. Now, for the image, I want to center my image horizontally, but also vertically. Same for my text here. Gonna change that to center horizontally and center vertically. Back to the vertical box, I'm gonna change the position to be 0 on X and 0 on Y. Now we can see that the vertical box is almost aligned perfectly. I just need to change the alignment from 0 to 0.5 on X and on Y. The moment I do that, we can see that everything is now perfectly aligned. So every time the player will interact with the object, this will be perfectly aligned and display in the middle of the component. So right now, for my case, I do not have any specific image, I just have a white cube, but this is where you would put an image, whatever you want to use, that can, for example, prompt the user to use a specific control, specific key on the keyboard to interact with objects. So this is all we need to do for the actual widget, for the actual UI interface. So I'm going to compile, I'm going to save, and now I'm going to implement that to whatever interactable object we have. In my case, I have my cube here, which is a BP interactable. So I'm going to open this blueprint. And on the viewport, you can see that I have the mesh. I have some interaction bounds here. This is the zone where the player will enter to see the UI text being displayed. And the moment the player leaves this zone, then the text will disappear. So in this component, I'm going to add a widget. So I'm going to look for a widget. Now inside this widget component, I'm going to change the user interface settings. So first I'm going to change the space. By default it's set to world. I'm going to change that to screen. With this change, the player will directly see the text being shown in the middle of the screen and wherever the player is facing. So if I move left, the text will adapt to always be facing the player, and if I move right, it will be the same. If I was keeping that to world, the text will be displayed in one direction and will only be accessible from a specific angle. By changing it to screen, the text will always be facing the player. And finally, for the widget class, I'm going to select the widget interact we created. Now inside the event graph, I need to make sure that once the player enters the interaction bounds, the text will be displayed, and once the player leaves it, the text will be removed. So to do that, in the event graph, I'm going to right click on interaction bounds here. I'm going to choose add event and on component begin overlap. This means that once the player is entering the interaction zone, then something will happen. At the same time, I need to create another event called onComponent and overlap. So every time we leave the zone, then something else will happen. In that case, what we want is the widget to be displayed or not. So I'm going to drag and drop the widget component inside the event graph. From the widget, I'm going to look for a set visibility node. I'm going to do that twice. So I'm going to look for set visibility again. I'm going to attach the begin overlap to the first set visibility event. And I'm going to change the new visibility to true. Every time we enter the zone, the text will be displayed, so the visibility will be true. And once we leave that, I'm going to change the set visibility to false. So the very top, new visibility is turned on, and the one at the bottom, it is turned off. Now I'm going to compile this, and save, and that's all we need to know. As a side note, I need to mention that the widget component is added to the blueprint, but we cannot really see it. And we kind of have to trust the engine here. And one last thing is on this widget component, I'm going to search for visibility, and I'm going to turn this visible setting to false. By default, it's turned to true, so it always will be visible. If I turn it to false, it will become visible only when the overlapping event happens. So by default, make sure to have the rendering set to false. So rendering visible false. If you don't do that, you will always see the UI interface being shown on the screen. So now I'm going to go into play mode. Look at my cube. I am far away from the interaction bound, so nothing is happening. I get close to it, and we can see the UI being displayed. Move away from it, it's now being hidden. And if I go left or right, it's always facing the player. So this is it for this video, and I will see you in the next one. Hello everyone. In this video, we will see how to create an outline shader in Unreal Engine 5. To do so, we're going to first create a material. So right click in the content browser, look for material, then choose material. Call that M outline. I'm going to open it. In the settings of this material, I'm going to change the material domain from surface to post-process. Then only one node is available, the emissive color. Now I'm going to create a new node, and I'm going to look for a scene texture. And from the color of the scene texture, I'm going to connect that to a lerp node. So lerp stands for linear interpolate, so the name is actually linear interpolate in Unreal Engine. Click on that. So this lerp will be connected into the emissive color. We see an error. It's because the scene texture ID is set to scene color. What we want here is post-processed input 0. The moment you do that, you can see that the error is gone. So in our lerp node, we have A, B, and then the alpha value. Right now, the A value is good, so we're clear for that. Now we want to have the B value. In this case, the B value will be the color of the outline. To do that, I'm going to look for a color node. So I'm going to look for constant, and I'm going to look for a constant 3 vector. Right here, I'm going to right click on that, and I'm going to convert that to a parameter so we can change the color whenever we want. And I'm going to call that color. This color will be connected directly into a makeFloat node. So I'm going to connect the red value here to makeFloat, and I'm going to look for makeFloat 4. So the red value will be connected to X, the green to Y, the blue to Z, and the alpha here will be also connected to the alpha of makeFloat. We're changing the parameter of this color to make that a float, which we will connect inside the lerp value. And instead of just connecting that to B, I'm going to look for a multiply node and another constant, but this time just a constant vector, which I will right click on and convert to parameter. Call that intensity. Actually, I'm going to call that glow intensity. And this will allow us to change the intensity of the color. So right now we have a color here that we multiply to this intensity, so we're getting the intensity of that color, which we can then use directly into B. This just allows us for multiple scenarios and creating different type of outlines. So right now we have the A and B value of the lerp. The most complicated one is actually to get the alpha value here. So the lerp switches between the value A and B based on this third value, the alpha value here. And here what we want is to get the depth of the scene, so we can see if the element is chosen, it will be highlighted, and how highlighted it will be. So let's get started. What I'm going to do here is just move that up and comment here, and I'm going to call that color. I'm just going to change the color of the comment. Here we go. And I will move back, and we're going to work on creating the alpha value. So I'm going to search for a node called view size, and from there I'm going to look for a sail node. Then I'm going to connect that to a clamp node. What we're doing here is we're getting this, the value of view size, and we are clamping that between 1 and 2. By default it's 0 and 1. We want to have 1 as the minimum value and 2 as the maximum value. Now I'm going to create another parameter, so I'm going to create another constant. This time once again a constant 1, so by default it's just called constant. And right click, convert to parameter, and this will be the width of the line. So while we created the color earlier, we still need to have the actual vision of what the line would be around the object. So by default, I'm going to leave this value to 0. Actually, I'm going to change that to, I'm going to change the default value to 0.5, but since it's a parameter, we can change that later on. This will be connected to a multiply value. and we're gonna get the clamp value inside the multiply. So here we're just creating the line around the object, but we still haven't defined how to know where the line would be. We have the size of the line, the value is clamped and all that, but we don't know around the object where this would go. To do that, I'm going to look for a node called scene texel size. This will be multiplied with the result of the previous multiply. From there, this multiply node will connect into two different nodes. First, I'm going to look for a mask, in this case component mask. By default, we have the RNG value, which stands for red, green, and blue. And actually I just want the red value here. And then I'm going to connect the multiply node to another mask component. And this time, I do not want the red value, I just want the green value. I will connect the first component mask into an append node. It's actually called append vector. And as you can guess, the second component mask will also be connected to another append node. So append vector. Make sure this is the append vector under math and not under vector ops. The red mask is connected to the A value of the append. The green mask will be connected to the B value of the append. Then I'm going to look for a constant, once again a constant 1. This time this will not be a parameter, I'm just going to leave the value to 0. And this will be connected to the first append in the B value, but also to the second append, but this time for the A value. Now that we have that, I'm going to create another constant, and this time the value will be -1. So right now things might be a bit confusing. What we are determining here is to show where the line will appear. So to keep going, I'm going to connect the append into a multiply node. And as you can guess, I will do that twice. In this case, multiply again. And just like the append nodes, this will go inside the B value. So the first append is connected to multiply on the A value, and the second append is connected to a multiply node, but this time for the B value. And exactly like before, I'm going to connect this constant we just created, which value is -1, directly into both multiply. So the first one for the B value, and the second one for the A value. So if I look into my material right now, we can see that everything kind of looks like it's very close to each other. So I'm going to move the color and the final material node more on the right. Now, I need to look for a screen position node. From there, I'm going to get another mask, so component mask. And this time, I will not change the default value of red and green. So the screen position allows us to get position of the player, so we can see based on this position, based on where the camera is, what will be outlined on the object. So I'm going to connect that into an add node. And what I'm going to do here is I'm going to create I'm going to create a total of 4 different add nodes. So add, I'm going to press Ctrl C and Ctrl V to go faster. So we have a total of 4 different add nodes. And I also want to get 4 different scene texture nodes. So I'm going to right click, look for scene texture. By default, the scene texture is set to scene color, but what I want here is depth. So I'm going to look for scene depth. We want to have the depth perception from the camera to see where the outline will be. Everything we're doing here is in 3D, so we need to have this depth value. I need a total of 4 nodes, so I'm going to copy and paste that to have a grand total of 4. So once again, I'm just going to move everything more on the right side, because this is taking a lot of space. And back into this material, I'm going to connect the first add node into the UV of the first scene texture, and I will do that actually for all of them. The second add node will be connected into the UV of the second one, and so on. Just gonna try to space things around. Here we go. And all those add nodes need to be connected. So what I'm gonna do is get the mask component we have from the screen position, the one where we are using the red and green value directly, and I will connect that into all the A values of all the add nodes. While this is great, we still need to connect something to the B value. So in this case, we're gonna get the result of the first append we had here, connect that to the B value of the first add node. Then I'm gonna get the multiply result, the first multiply result, connect that to the second add node. Then the second append node at the bottom here will be connected to the third add node into the B section. And finally, the result of the second multiply, the one that's at the very bottom, will be connected into the B section of the add node. Now, we have 4 different values here, and what I actually need, I just realized that I said we need the scene depth. What we actually need is custom depth. So I'm just going to change that in all of my nodes right now. So here we go. And what I'm going to do is I'm going to copy one of those nodes, Control C and Control V. So I have a grand total of 5 different scene textures, and all of them are set to custom depth. This one will not be connected to anything on the UV side. However, the color result of this custom depth will be connected to a subtract node. And what I'm going to do here, just like the add nodes we created earlier, I'm going to copy and paste all of those. So I have a total of 4 different subtracts. The very top custom depth node, its color is connected to the first subtract. It will also be connected to all the subtract nodes into the A values. So I'm going to get color, all of them into A. Now that we have all the A values for the subtract nodes, I'm going to need to get the B value. In this case, this is actually very easy. We just need to connect all the scene textures to the B values. So the first scene texture, the one that is connected to an add node, so I'm just going to ignore the very top one here. The one that's connected to an add node in the UV, I'm going to get its color and drag that directly into the first subtract. For the second one here, I will also get the color and drag that into the B node here of the second subtract. For the third one, I'm going to get the color, connect that to the third subtract into the B value. And finally, the last one, get the color and connect that to the B value. Now we're almost done. We just need to get an add node here. So the first subtract is connected to an add node, and we need to add the result of the first subtract and the second one. And the third subtract node will also get to another add node, where we get the result of the third subtract node and the fourth subtract node. So in here, you should have something that looks like that. Both subtract 1 and 2 are connected into an add node together, and 3 and 4 are also connected to another add node. And we also want to get the result of both these add nodes, so I'm just going to get another one, and I'm going to connect the result of the first add node into A, and the result of the second add node into B. So at the end, we have all this operation, all this calculation. We're getting the depth of the scene, we're getting the lines, the width of the line of the outline. All that ends up in one single value here, which is the result of this add node. And we are almost there. So I'm going to connect the result of this add node into a divide node. And this divide node will be attached to another constant. So in this case, look for constant. Or if you want, you can just press 1 on your keyboard. Press 1 and then just simply click into the material editor, and this will create this value this time will be hard-coded to -100. Finally, I'm going to connect the result of that into a subtract. And we are just going to subtract 1 to that. So by default, b is set to 1. That's all we need to have. And I'm going to get a clamp node here. By default, the minimum value should be 0 and the maximum value should be 1. We will keep those values. So we want to have the result of all of this operation set between 0 and 1. This is why we need a clamp here. And this clamp will be connected to the nub. The alpha value of the nub should be set between 0 and 1, so this is why we're clamping this here to make sure that we don't have a higher or a smaller value for some reason. And this is pretty much all we need to do here. So now I'm going to save this material, go back into my scene, and I'm going to add a volume. And actually I want a post-process volume here. If, just like me, you have a post-process volume already in your scene, you don't have to create a second one, so I just did that for the sake of the example, but I'm going to delete that. And in this post-process volume, I'm going to search for infinite extent, and I'm going to make sure this is checked on to true. Now I'm going to look for material, and under your post-process volume, you should have a post-process materials. By default, it should be an array with 0 element in it. So I'm going to add an element, and I'm going to click on choose and asset reference. What we see here is we have none in the array. I'm going to drag and drop the material outline we just created and put it right there. So now this post process has a material, but nothing is happening here. We can see that there is no outline anywhere. So what we need to do is for each object we want to outline, for example, I'm going to select this cube. I want to look for depth into the search bar here. And we can see that under rendering, into the advanced settings, there's a value called render custom depth pass. We want to turn that to true. And we can see that we have an outline here. Because I did not change the color of my outline, we barely can see it. So what I'm going to do is go into my material, change the default color from black to something white, and change the glow intensity to 10. And now we can see that the object is outlined. So by default, this material, if I can create an instance of this material, I'm not going to rename that, so it's just going to be called material outline instance. If I open that, you can see I can choose the width, the intensity, and the color. I can change that to, let's say, blue color. I want to have a very thick line and a very strong intensity. So I put 10 for the glow intensity, 10 for the line width, and the color is a bluish. Back into my post-process volume, I can look into materials again and change this R element to the instance I just created here. And we can see the outline is very obvious here. It's actually a bit too much, but it's working. So we can just change values. Let's say I want a small line, 0.5, I'm gonna save. And here we go. So this is it for this video, and we'll see you in the next one.